So what strategy could you use if you were given the following fractions? 9/12, 5/12, 3/12. Consider the language that you use and try to make sure it's conceptual. So for problems like this, we're going to use a strategy called the same denominator strategy. You may be familiar with this strategy under a different name called the common denominator strategy. It's the same strategy. We just like to call it the same denominator strategy because it's quite a bit more intuitive for students. In order for students to use this strategy, they have to notice that the two fractions have the same denominator. And when two fractions have the same denominator, both fractions use the same sized pieces. We know this because the whole units are the same, and each whole is partitioned into the same number of equal-sized pieces. So, if the pieces of the two fractions are all the same size, the greater fraction is the one with more pieces, a higher count determined by the numerator. So this same denominator strategy could be articulated like this. All the fractions have the same denominator, so you just put the fractions in order by looking at the numerator. But this kind of sounds like a rule. So I'd encourage you to make sure to keep the concept at the forefront. So they have the same sized pieces, so what you're counting, and we're focusing on the number of pieces that you have, which is the count. And that information comes from the numerator. Here's another problem. Consider ordering these fractions from least to greatest. 4/9, 4/6, 4/3. One thing to notice is that all of these fractions have the same numerator, but different denominators. So we're going to use a strategy called the same numerator strategy. Again, you may have seen this called the common numerator strategy, and it's the same strategy, but we're calling it the same numerator strategy because we think same is a little more intuitive than common. So students have to notice that the two fractions have the same numerator. When the two fractions have the same numerator, that means they have the same count, or the same number of pieces. So if two fractions have the same number of pieces, then students just need to know which pieces are bigger. The fraction with the lesser number in the denominator has the larger pieces because it takes fewer of the pieces to make the whole. So this strategy could be articulated as follows. All the fractions have the same numerator, so you just put the fractions in order by putting the denominators in opposite order. This sounds like a rule, and there's a good possibility that they'll forget or get wrong, get backwards. So we want to make sure that in articulating these strategies, we keep the concept again at the forefront. So fractions have the same number of pieces, and the lesser the number, or the numeral in the denominator, the fewer pieces it takes to make the whole. So those pieces will be bigger. So this is more conceptual. This next activity has you articulating how it is you know that a fraction is less than, equal to, or greater than 1/2 by writing equivalent fractions to 1/2 on this middle line, and then to the left of that line, writing some fractions that you know for sure are less than 1/2, and on the right of that line, fractions that you know for sure are greater than 1/2. And then in the boxes below, you're asked to write some reasoning about how you know that the fraction is less than 1/2, exactly 1/2, or greater than 1/2. And I'd encourage you to look at first how you know that a fraction is exactly equal to 1/2. And it probably goes something like this. A fraction is equal to 1/2 if we have half the number of pieces that it takes to make a whole, then the fraction is equivalent to 1/2. In other words, if the count is half of the number of pieces that it takes to make a whole, then the fraction is equivalent to 1/2. And then we can say the fraction is less than 1/2 if the number of pieces that we have is less than 1/2 of the number of pieces it takes to make a whole. And the fraction is greater than 1/2 if the number of pieces that we have, the numerator, is greater than the number of pieces that it takes to make a whole, the denominator. Consider the following problem. We want to order these fractions from least to greatest. Notice that one of these fractions is equivalent to 1/2. One of these fractions is less than 1/2, and the other is greater than 1/2. So we're going to call this strategy straddling the benchmark. And in this case, it's straddling the benchmark of 1/2. We could use other benchmarks, like often we'll use benchmarks like 1. We could use 1/3 or 3/4 or any other number, but is our benchmark to straddle, like where one fraction is less than that benchmark and the other fraction is greater than that benchmark. But this strategy is valuable when one of the fractions is less than the benchmark and the other fraction is greater than the benchmark. And in this case, we're focusing on 1/2 being our benchmark. So compare the multiplicative relationship between the numerator and denominator in each fraction, where the numerator is less than, equal to, or more than half the denominator. In other words, the number of pieces that we have is less than, equal to, or more than half the number of pieces that it takes to make a whole. If the numerator is less than half of the denominator, then the fraction is less than half, because the count would be less than half of the pieces it takes to make a whole. If the numerator is greater than half of the denominator, then the fraction is greater than half, because the count would be greater than half of the pieces it takes to make a whole. So far, we've got 3 conceptually based fraction comparison strategies that we can apply to a given situation where they are applicable. We've got the same denominator strategy, the same numerator strategy, and the straddling the benchmark strategy. Often the benchmark is 1 or 1/2. We want to keep making sense of fractions by continuing to emphasize that students compare fractions by making sense of their magnitude instead of going to a procedure. Several things are happening as students are trying to make sense of fractions. Their brains are starting to look for patterns, for shortcuts, and, unfortunately, in their quest for the superficial shortcut, they develop invalid fraction comparison strategies that are so subtle and that work most of the time that they can go unnoticed by us until these invalid strategies, unfortunately, become the go-to fraction comparison strategies for our students. So we have some strategies that will help us compare fractions. We've got the same denominator, same numerator, and straddling the benchmark strategies. And just keep in mind that the straddling the benchmark of 1/2 is restricted to when one of the 2 fractions you're comparing is less than 1/2 and the other is greater than 1/2. If we have 2 fractions where one is less than 1 and one is greater than 1, then we could be using the straddling the benchmark of 1.